It's been almost 5 decades since humanity first sent Voyager 2 into the void. Decades of whispers from the edge of the sun's influence. Now imagine the day we receive one last message, a haunting signal, buried in static, confirming something we dared not hope to prove. What does it tell us? What lies beyond our heliosphere? And most ominous of all, what do we fear about the cosmos, and what might that signal confirm? Tonight we explore the possibility. Voyager 2's final transmission, real or imagined, confirms what we all feared. We'll journey through Voyager's storied past, its status today, the frontier of interstellar space, and the hypothetical revelations that such a signal might bring. Together we'll ask, are we ready for what lurks beyond the veil? Let's begin. A mission launched in hope. In August 1977, NASA launched two spacecraft, Voyager 1 and Voyager 2, with a bold ambition: explore the outer planets and then push onward into the unknown. Voyager 2 lifted off on August 20th, 1977. Its early mission was a grand tour of the solar system's giants: Jupiter, Saturn, Uranus, Neptune, the only spacecraft to visit Uranus and Neptune in close flybys. But from the start, the designers hoped the probes would outlive their original 5-year mission. They carried instruments to study plasma, magnetic fields, cosmic rays, imaging systems, and more. Each passing planetary flyby rewrote textbooks. New moons, ring features, atmospheric dynamics, and magnetospheres we had never dreamed of. Voyager 2's discoveries were profound. At Uranus, it found 10 new moons and 2 new rings. At Neptune, it revealed 5 moons, 4 rings, and the ominous Great Dark Spot storm, with winds reaching approximately 2,400 kilometers per hour. It observed geysers on Neptune's moon Triton, blasting plumes kilometers high. A surreal, active moon in the cold outer reaches. After its planetary tour, Voyager 2 didn't retire. Instead, it journeyed into what we call interstellar space, the domain beyond the influence of our sun's solar wind bubble. On November 5th, 2018, Voyager 2 officially crossed the heliopause, joining its twin, Voyager 1, in interstellar space. It carries the golden record, a message from Earth, music, images, greetings, a cosmic time capsule. Yet today, decades on, its power is dwindling. Its instruments are being shut down one by one. In 2024, NASA shut off its plasma science instrument to conserve power, further shrinking what the probe can send back. Still, Voyager 2 continues to whisper, measuring magnetic fields, plasma waves, cosmic rays, clues to a region no human has physically been. But what if one day we get one last message, a final transmission? What might it contain? What might it reveal? The edge of the bubble, where the sun's voice fades. To understand what a final message might confirm, we must first understand what Voyager 2 is flying through. The boundary between solar influence and interstellar space is neither neat nor simple. Our sun emits a constant stream of charged particles, the solar wind, pushing outward, forming a bubble in space called the heliosphere. That bubble shields the inner solar system from much of the galaxy's harsh radiation. But as the solar wind expands, it slows, eventually reaching a termination shock, where it transitions from supersonic to subsonic relative to the ambient interstellar medium. Voyager 1 crossed this in 2004. Voyager 2 did so in 2007. Beyond that lies the Helios sheath, a turbulent region of slowed solar wind mixing with incoming interstellar particles, magnetic field fluctuations, and shock effects. At the far boundary sits the heliopause, where solar pressure is balanced by the interstellar environment. That is the frontier. Beyond it lies true interstellar space. Crossing that boundary, Voyager 2 entered a realm of mystery. Plasma densities change, magnetic field structures shift, and cosmic ray counts surge. Voyager's instruments detected anomalous cosmic ray behavior. Particles accelerated at shocks or reconnection zones. In 2023 to 2024, researchers noticed unexpected density increases in the local interstellar medium, VLISM, indicating that the veil beyond the heliopause might be more structured than previously thought. A 2022 study modeled shock-wave heating in the outer solar wind, showing that shock structures could sustain higher temperatures than predicted in a purely adiabatic expansion. Another study of Voyager 1 and 2's crossings showed a symmetry likely caused by the local interstellar magnetic field's angle relative to solar wind flow. So the environment is dynamic, complex, and surprising, and that's before we even imagine what a final message might carry. The silence and the signal, communications at the void's edge. Every communication from Voyager 2 is a triumph over distance, power loss, and cosmic interference. As it drifts farther away, data rates shrink, signals weaken, and ground teams must push the limits of detection. At launch, Voyager 2 could transmit at approximately 115.2 kilobits per second when near Jupiter. Today, its transmission speed has dropped to just approximately 160 bits per second, a whisper across billions of kilometers. In July 2023, a miscommand caused its antenna to point away from Earth by approximately 2 degrees, cutting off communication. NASA's Deep Space Network used a shout, a high-power command to reorient the spacecraft, and communications resumed on August 4, 2023. Still, with one-way light time nearing 18.5 hours at that distance, each command and reply is a long wait. Given power constraints, NASA has been gradually turning off non-essential instruments to conserve energy. In February 2025, Voyager 1's cosmic ray subsystem was shut off. Similarly, Voyager 2's low-energy charged particle instrument was slated for shutdown in March 2025. In effect, the mission is entering a slow fade mode. Each instrument closure brings it closer to silence. If the spacecraft were to send a final transmission, it might arrive when only its highest priority subsystems remain. The content would have to overcome enormous noise, compressed bandwidth, and possible degradation of hardware. Such a message might emerge as a last telemetry burst, a cryptic anomaly buried in noise, a sudden spike in cosmic ray or magnetic field data. Something not anticipated, something that forces reinterpretation of interstellar data. Now we arrive at the speculative center. What if that final transmission confirms something we fear? What we all feared. A hypothetical revelation. Let's imagine the final message arrives. Sparse, weak, but real. In the static, buried in bits, we decode an unmistakable pattern, a signature that confirms something we long suspected but never proved. The cosmos is far more hostile and structured than imagined. What might this fear be? Here are a few possibilities, each speculative, but grounded in scientific plausibility. 1. A barrier beyond the heliopause. The transmission could show that as Voyager 2 passed out of the heliosphere, it encountered a harder boundary, a shell, shock wave, or unstable plasma layer that's more than a gradual interface. Such a revelation would force us to rethink how solar and interstellar pressures interact. 2. Magnetic reconnection or plasma veil. Data might reveal extreme magnetic reconnection or plasma turbulence at the boundary. Energetic events that inject turbulence into interstellar space. A veil that scrambles fields, absorbs high-energy particles, and distorts signals. This could mean our sun's protective shield rarely transitions smoothly. 3. Cosmic ray horizon. Perhaps the final signal includes measurements showing cosmic ray fluxes rising to levels previously assumed impossible close to the heliopause, confirming that unshielded space beyond carries lethal radiation gradients. If true, this would underscore the vulnerability of future probes or humans venturing into deep space. 4. Evidence of large-scale structures or fields. Maybe the transmission contains data of an unexpected large-scale magnetic field or structure, a filament, shock front, or even a boundary of a nearby interstellar cloud interacting right at the edge. That might confirm a hidden architecture to our local galactic neighborhood. 5. A cryptic foreign imprint. This is more speculative. The signal might carry odd modulation or patterns, harmonic resonances, mathematical spacing, or data structures inconsistent with natural processes. If so, It could hint at an interception or reflection from unknown astrophysical phenomenon, or even technosignature echoes. But we must stress, this remains speculative and not currently supported by verified sources. In this scenario, the thing we all feared, is that interstellar space is not empty, tame, or uniform. It's dynamic, violent, structured, and perhaps even encoded with surprises we cannot yet parse. If that final message confirmed any of these possibilities with high confidence, it would shake astrophysics, space travel planning, cosmic ray protection, and our understanding of the local galaxy. But is there even a hint of such a possibility now? Clues from today, hints we can see. While no final transmission has occurred, we already see hints in Voyager 2's data that the boundary region is more complex than once thought. Recent detection of increasing plasma density beyond the heliopause suggests the very local interstellar medium is not homogeneous. The shutdown of key instruments means that some measurements may be lost forever. Data that could have given deeper insight may vanish before we receive it. The anomalies in cosmic ray acceleration, the Voyager paradox, where expected local peaks were absent, hint that particle acceleration at the heliospheric boundaries is not fully understood. Studies modeling shockwave heating show non-adiabatic temperature profiles that diverge from simple models, underscoring ongoing turbulence in the solar wind beyond. Multi-point comparisons between Voyager 1 and 2 have shown that transient pulses, GMIRS, propagate through the helios sheath, altering pressure, flow, and particle intensity. Thus, the environment is not inert. It is dynamic and evolving. A final transmission, if strong enough and intelligible, might peel back one more layer of that envelope, confirming suspicions we now can only outline. What it would mean: scientific and human implications. Assuming a final transmission confirms one of those fearful revelations, what follows? How would science, exploration, and humanity respond? Rewriting boundary physics, we'd need to revise models of heliosphere-interstellar interactions. The new data would feed new simulations, possibly revealing that our sun's bubble is less protective than assumed, and the boundary more turbulent. Deep space mission design. Any future interstellar probes would require hardened shielding, redundant communications, and perhaps safe corridors through less active boundary zones. Human spaceflight considerations. If cosmic ray gradients near the boundary are steeper or more hostile, missions to the outer solar system, or beyond, must plan far more massive protection for astronauts or habitats. Galactic neighborhood mapping, discovery of magnetic filaments or boundary shells would motivate mapping of our immediate interstellar surroundings. It could open a new subfield, cosmic boundary cartography. Philosophical impact. A revealing signal that shows the cosmos has hidden structure or danger at our doorstep would deepen existential questions. Are we safer within the heliosphere than we realized? Are cosmic hazards lurking just beyond? However, and critically, we must maintain skepticism. Any final transmission claim would require rigorous verification, cross-checks from ground stations, signal integrity tests, and peer review. So far, Voyager 2 has not sent a known final transmission, but we must treat this scenario not as science fiction, but as a thought experiment grounded in existing data and realistic extrapolation. Voyager 2 continues to operate, measured and persistent. Every day it defies expectations, sending us data from a frontier no human has reached. That in itself is miraculous. The shutdown of instruments is part of the mission's gentle decline. Each day, power margins shrink. Soon, perhaps in the late 2020s, it will reach the limit where it can no longer sustain any communication. If a final transmission arrives, buried in noise, barely above threshold, we must treat it with scientific rigor. It will require cross-verification, error rejection, and cautious interpretation. Yet envisioning what it might confirm is a useful exercise. It prepares us to recognize surprises, that boundaries may not be smooth, cosmic rays may rise unexpectedly, and interstellar space may carry hidden architecture. For you, the viewer, the key takeaways. Voyager 2's mission remains one of our most enduring scientific legacies. The boundary of the sun's influence is complex, not a clean edge. A final message, hypothetical though it may be, could confirm radical surprises about our cosmic neighborhood. Even without that, every bit of data Voyager sends is precious, valuable, and pushing knowledge at the very edge of what's possible. Here are some questions to ponder. What if interstellar space is more dangerous or chaotic than we imagine? Are we underestimating the challenges of sending probes, or even humans, beyond the heliosphere? If a final whisper arrives from Voyager, would we be ready to listen and interpret it with care? If you enjoyed this exploration, please like this video, subscribe for more deep dives into space exploration, comment your thoughts. What final message would you want from Voyager? And check out these related videos on Voyager's discoveries, interstellar medium, and future missions to the stars. Until then, when you look up at the night sky, remember, out beyond the sun, one of our oldest emissaries still drifts, sending whispers across the void. Maybe one day its last whisper will tell us something we feared to know.